What is up, guys? We are running a little bit late tonight, but we're back with day 3 of Advent of Code 2023. What I've got for you today is a kind of an early 2D grid challenge. So I've got the sample input here on the screen, and what we had to do today was search through this grid and locate these symbols. And from there, we were supposed to find numbers adjacent to these symbols and add them up, if I remember correctly. So that's what the sample input looks like. Now let's hop over to the code. Okay, so again, we're going to be setting our field separator in AWK to the empty string so that we'll assign the fields to individual characters. On each line of the input, we're going to loop over those characters and put them into our grid. So we do get to learn a new AWK concept today. What you're looking at here might look kind of like in Python, or at least with NumPy, a multi-dimensional array. But technically, AWK doesn't have multi-dimensional arrays. They just let you combine two indices into one, like super index. So we can emulate 2D arrays, even though they don't technically exist. So that's how we're doing here. We've got a C-style for loop where the braces are optional. So for each field in the input line, we put it into the grid. And as I mentioned, I think in the first day's video, $0 represents the whole line. So I'm also saving up each of the lines. NR is another special variable that stands for record number, or basically line of input in the current file. So we're just storing all of those for later. And then we also want to know how many fields there are in each line. So I'm saving this as well. And as the comment says, I'm assuming they're all the same. I'm setting this on each input line. Okay. So once we store our grid in a form that AWK can use, in the end block, basically all we do is loop back over it and perform a couple of checks. So as you can see here, we're looping over rows. And in part 2, I do rename this to call, like column. So in this for loop, we're looping over columns. And between the two of them, we'll cover our whole grid. So the first thing we do, I assign the output of this check function, which we'll talk about in a second, to C. And then I say if the grid position that we're at, row, I, matches a number and our check passed, then we call this other function current and then add that to our total. And at the very end, print the total. So now all we have to look at are what is this check function and what's the current function. So I actually made some decent comments this time. You can see that check, although I didn't give them very descriptive names, check basically does a grid search, as you can see, from row -1 to row +1, and from I -1 to I +1. So we're just mapping out the 3x3 grid centered on whatever grid element we're on. So we do that just with a couple local variables. As I talked about in the last video, we loop from row -1 up to row +1, incrementing, and same thing with k. And of course we skip ourselves. I guess we don't have to do that because we're checking if JK, grid of JK is a symbol, and we know it's a digit, so we could probably leave this out. But yeah, we just check if it's in the grid. So this is actually pretty Pythonic. If you're familiar with Python, we're checking if this index is in the grid. And it's good to do it like this instead of just skipping to this, because I believe that even indexing it will create an empty element in your array. So if you want to avoid that, you should do it like this. JK in grid and grid JK matches one of our symbols. Then we just return it. If we don't find it, we return 0, which is going to be falsy. So again, that's how we identify if the number, if our rowth, ith element is of interest. And then what we do is we call this current function. And again, I wrote a comment that says we find the whole number that the current digit is part of. So if you pay close attention, you'll know that this element here, grid of row, I, is a single digit. But what we need to do for the challenge is capture the whole number that this is part of and actually add that up, not just the single digit. So that's what this is doing. Here we don't have to do a grid search because the numbers can only be on one row. So we search first to the left on the row, looking for the beginning of the number, as again the comments say, search left first. while it matches a number. And then we search right, looking for the end of the number. And the final touch here, actually much like the first day where we were dealing with overlaps, we need to prevent overlaps again by advancing our I in our main loop out here to be beyond the end of the current digit. So there we go. Once we identify our J and K indices, advance this, this pointer, I guess I'll call it, we just take the substring from the full row and return that. And that's what we add to our total. So I guess I'll go ahead and run that. And you can see we get the correct answer. Moving on to part 2. Okay, now looking back at our sample input file again, as usual, the challenge changes slightly. So this time, instead of looking for numbers adjacent to any symbol, we're actually looking only for asterisks, which represent gears, which I guess is where the day gets its name. And we are in particular interested in gears, or asterisks, that are adjacent to 2 numbers. So the reason I had this one selected is this is one of the examples, whereas this one is only adjacent to 1 number, doesn't count as one of the gears we're interested in. And it has to be exactly 2 numbers, so we don't have any cases here, but in theory they could be adjacent to 3 or more digits probably. So this one and this one, we would have to find them, find the 2 numbers adjacent to them, and then multiply those numbers together and sum that up. So that's what we have to do in part 2. Jumping back over to the code, you'll notice that a lot of it is very similar. So of course, we're going to start off with our same field separator, and the whole grid initialization is exactly the same. The main loop here is, the main 2 loops here are quite similar as well. And even our condition here is similar, but we've basically had to swap, at least the way I did it, I've swapped what I'm searching for. Previously, I was searching for numbers here and symbols here, but now I'm looking for the gears in the main loop, and then I'm calling check, which has been rewritten, but not had the comment updated. So now what I'm doing is I'm starting from an asterisk, and I'm doing a grid search outwards for numbers. And so there's some complexity here that took me a little bit of time to work out. So these loops should be the same. We're still continuing if we hit the same thing. And the test is almost the same, but again, we're looking for digits. However, we've moved our call to current in here. We've introduced this new variable called prod. And we've also got this new thing called jump. So let's talk about each of those in turn. But first, we'll take a look at our new current implementation. So actually, it's fairly similar where we're still finding the whole number. But this time we had to add some actual arguments, because before I was using the global row and column identifiers to start searching from the current, what I was calling the current position. But now we don't have a current position per se. We actually have to call it in this loop. So otherwise, pretty similar, looking for digits, J minus minus. I did have to add this additional condition because I think my K was getting like too far over. In theory, I should have been checking this before, but this match was failing before because the index didn't exist. So it's not strictly necessary. So again, we're doing our left and right search, looking for the whole number. And the reason I had to introduce this jump equals K thing is because we no longer, sorry, I probably could have done it actually like the other one without the jump. But what I came up with was I'll just set this global variable instead of messing with one of the indices. Yeah, I would have had to make one of these indices not local and modified that right here. But anyway, I did it a different way. And then we've got our same substring here. So we are looking for 2 digits. That's what this n variable is for. And if n equals 2, that's when we enter this. And so we access the prod variable that we're setting in here. So again, we're kind of modifying this global state and then conditionally accessing the global state when check returns true, basically. And the reason we're doing this is because I didn't want to have to think about, oh, is the number, like, have we only seen 2 before I did the multiply? You'll notice actually that this function doesn't even mention that we're looking for an exact 2 matches until the very end. So we just add up all the matches we find, and then we decide if we should include it later or not. So anyway, it's getting kind of late. That one didn't seem as coherent as some of my other explanations, but as always, thanks for watching, and I'll see you guys tomorrow with another video. Have a good one.